Hello students, let us continue our discussion on units and measurements. In the last session, we discussed about mathematical way of representing errors, and we also discussed about the propagation of errors in mathematical operations like addition, subtraction, multiplication, division and raising to the power of certain value. So those things are all done with errors. And in this session, we are going to see significant figures. Significant figures. It is also considered as significant digit. I hope, I think you have studied this, learned this in chemistry also. I will also study the same thing here. So when I say significant figure, whatever the measurement that we have, right? See, it's all about units and measurements. If I measure something, I will keep certain value, right? But uh, certain digit, the value cannot be taken and proceeded, taken continuously for any number of decimal points or any number of digits. For example, as an example, say I'm measuring the uh, velocity of a particle. The distance traveled by the particle is 10 meters and the time taken by the particle is 3 seconds. Okay, 10 meters is the distance traveled, 3 seconds is the time taken. So according to the formula, velocity becomes v is equal to distance by time 10 by 3. What is 10 by 3? 10 by 3 is going to be 3.3333333 so on, infinite number of threes, recurring, right? So when this is the kind of situation, we need to have an idea of significant number of digits, okay, which means the important number of digits in this value what we have here, because see I can round it off to 3.3 3.33. I can also take it as 3.333. How do we keep the actual measurement of velocity? This all these things of keeping the values to certain number of digits or restricting the values to certain number of digits, everything like that is studied now. Okay, so this is the significance or this is the importance of discussing about significant figures of a given number or given measurement to be perfect. So now once we have a measurement, we will see the significant figure of that measurement. So there are few rules which has to be followed. Okay, few rules has to be followed uh, while counting the significant figures in a number. The number can be anything like 1500, 8450, 0.8593, 1.6256, something like this. The number can be anything, and in that given number, we need to get the significant digits or significant numbers. We need to count the significant digits and get the significant figures out of them. Okay, so let me define these significant figures first. The reliable digits of a number. Okay, the reliable digit of a number plus the first uncertain digit, the first uncertain digit together is known as significant figures. Okay, so when we have the value of certain measurement, in that value we will have Obviously not all the numbers are important for us. As you just saw, we need to restrict ourselves to certain number of digits in the number. Okay, like this 3.3333, where should we stop? We should have the idea that is obtained using this. So among that 3.3333, we will see the first uncertain digit. Uncertain means that digit is a part of error in the measurement. Okay, yeah, you'll get to know as the uh, concept moves ahead. You'll get to know everything with the examples. Okay, you keep this much in mind, that's enough. We'll get the clarity once we move ahead. But yeah, now we'll see few rules for counting significant figures in a given number. Okay, the first rule, okay, rules for counting significant figures, in a given number. Okay, the rules are as follows. First rule is, see, the number should be decided. This is the number. Say I'm measuring the time. It is 10 seconds, 5.3 seconds. If I'm measuring the length, 3.56 centimeters or 5.892 meter. These are the numbers which we have. These are the measurements that we have. In that measurement, again, not all the digits are significant. There are uncertain and insignificant digits included in that. So we should now see the rules for counting the significant figures. The first rule is, all non-zero digits are significant. All non-zero digits are significant. As an example, say if the number or the measurement that I have is, say, 5022, then in this, okay, let me take another example, not this, we'll take this later. Say the number is 5422. In this kind of situation, for this number, the number of significant figures, okay, so the total number of significant figures in the given measurement is, see, according to the rule, all non-zero digits are significant. So I should count how many non-zero digits are there. Okay, 1, 2, 3, 4. So for this measurement, okay, it's a measurement actually, say its length, so that the complete value becomes 5422 meters. So for this number, I have 1, 2, 3, 4 significant figures. Okay, so that is what is first rule. Very simple. All non-zero digits are significant. Okay. Next, all zeros between two non-zero numbers or non-zero digits, all zeros between two non-zero digits are significant. So this is the second rule. I'll take the example, you'll understand easily. Say the example is 4003. Very simple number, 4003. Say let this be volts. Okay, potential difference, voltage, 4003 volt. So this is the voltage measurement that I have. Okay, quantity can be anything, voltage, length, volume, anything. It's only about the number which we are concerned about now. Number, the value of the measurement. 4003, 4003. So according to the rule, now we should get the total number of significant figures in this. Is the value 4 significant? Yes, it is, because the first rule says all non-zero digits are significant. 4 is a non-zero digit, so it is significant. Is this 0 significant? Yes, it is, because this 0 lies between two non-zero digits. See, this 0 is between 4 and 3, isn't it? This 0 lies between 4 and 3, and 4 and 3 are non-zero digits. So, this 0 which lies between two non-zero digits is also significant. Even this 0 is also significant. 3 is also significant because it's a non-zero number, non-zero digit. So, altogether, even this number now has got 4 significant figures, right? Easy. Now, the third rule, all trailing zeros before decimal point are insignificant, So, this might look like little weird for you, because the example goes as such. If I have a number, say 2500 meter length itself. In this number, if I say what is the total number of significant figures in this? 2, is it significant? Yes, it is, because it is non-zero. 5, is it significant? Yes, it is, because it is non-zero. This 0 is the trailing 0. So, according to the third rule, all trailing zeros before this decimal point. So, this is the decimal point, before decimal point. Okay, it can be written as before decimal point or zeros to the left of decimal point. Okay, to the left of decimal point, because this is where the number ends, right? This is where the number ends, and zeros are to the left of the given value. So, if this is the situation that we have, then these two zeros are insignificant. They are not significant for this kind of measurement. So, this value 2500 meters has only two significant figures. Which are those? Two significant figures. One is 2 and the other is 5. So, only two significant figures, because the trailing zeros of a number are not significant. Okay. The more proper way to put this is, all trailing zeros, this before decimal point, after decimal point comes only if we have a decimal point. Okay. So, I can put this as all zeros, okay, all trailing zeros in a number without decimal point. That would be more proper. Without decimal point. Okay. All trailing zeros in a number without decimal point are insignificant. Okay. So, the number that I have considered here should not have any decimal point. Then this numbers trailing zeros, this 0 and this 0, both are not significant. Okay. So, that is about, see, you might think, okay, fine, why not? Because 2500 is the value. Mathematically, if we neglect these two zeros, we cannot decide whether the value is 25 or 250 or 2500, isn't it? That's how you might think like. But actually, We are not bothered about the values, instead we are bothered about what kind of measurement is done. So there are two digits, two significant figures, 2 and 5, that's fine. And then we have the unit meter. So one thing is clear, the unit is meter. So now we are clear that the least count of that given measurement is 1 meter. So the given arrangement, the given instrument for the measurement cannot measure something less than 1 meter. That is why it stopped at 2500 meter. So whether it is 2500 meter or 250 meter or 25 meter, it's always only 1 meter, which is the least measurement that can be done with this measuring device. Okay, so it doesn't matter if it is 25 meter, 250 meter, 2500 meter, it doesn't matter for us. What matters is it can measure at least 1 meter, okay, not less than that. So the least count of this measurement is 1 meter. We can have the idea of that using only these two digits. Okay, that is why these two digits are considered to be insignificant. Okay, so these are the three rules. There are few more, we will see those rules now. Next, the fourth rule is, if the number is less than 1, if the number is less than 1, then all the zeros, all the zeros, 0 or zeros to the right of the decimal point, the right of the decimal point, but to the left, but to the left of first non-zero digit, first non-zero digit are not significant. Okay, so if the given number is less than 1, how do we write the number which is less than 1? It's always something like 0 point something, isn't it? 0 0.12, 0 0.53, 0 0.0083, somewhat like that. So if the number is, example, if the number is 0 0.0082, say this is the number. So according to the rule, this number is less than 1, yes it is. So all the zeros to the right of the decimal point, see we have 3 zeros here, all the zeros to the right of the decimal point, which means these two zeros, okay, all the zeros to the right of the decimal point, but to the left of the first non-zero digit. See, 8 is the first non-zero digit in this number, so this 8, the number, the digit or the zero to the left of this first non-zero digit has to be considered. So this 0 and this 0, both of them are to the left of the decimal point and at the same time to the left, to the right of the decimal point and to the left of the first non-zero digit 8. So these two zeros are not significant. Okay, so these two zeros are not significant. And so if I ask to write the significant figures for this number, then it is going to be only 2, 1 and 2. So it is two significant figures for this number according to the fourth rule. Yeah, we also forgot about this 0. Yeah, even this 0 is not significant, right? Because it is to the left of first uncertain digit, first non-zero digit. So this is also uncertain. That is why it is only two significant figures for this given number 0.0082. And the next rule is, if the number Now what we had here is all zeros. If all trailing zeros in a number, right? Again we are going to consider trailing zeros. All trailing zeros. Trailing means ending zeros. If we have zeros in the ending of the number, okay, then we call them as trailing zeros. All trailing zeros, all trailing zeros excuse me, yeah, all trailing zeros of uh, of a number yeah, here it was without decimal point, and now it is about with decimal point. All trailing zeros of a number with decimal point with decimal point are significant. So, as an example, say I have a measurement like 5.800 meter. So, if I am asked to find the number of significant figures in this measurement, then I will count it. 5 non-zero digit significant, 8 non-zero significant. These two zeros at the end, and this is the number with decimal point. So according to the fifth rule, these two zeros are significant. So this 0 and this 0, both of them are significant according to this rule. You might think here we did not consider these two as significant because this number did not have any decimal point, but that number has a decimal point and trailing zeros. If the number has decimal point and trailing zeros, then those zeros are significant. If the number do not have any decimal point but still has trailing zeros, then those zeros are insignificant. So here these zeros are significant. Why is it so? You might think of it like this. The reason being, see, these zeros are showing us how detailed the measurement is. See, if I, okay, there is no difference if I write the same value as 5.8 meter, isn't it? There is no difference in among these two numbers mathematically, not physically. Because when we do the measurement, it's not only the number, it's also the details and units involved in the number which are also important for us. Details means, see, if I simply keep it as 5.8 meter, that's it. It can only measure 0.1 meter. It cannot go beyond or it cannot measure lesser than 0.1 meter, like 0.05 meter, 0.02 meter cannot be measured using this measuring device. So, if I have the measurement like this 5.800 meter, it means that the instrument that made use of to measure this value is can measure till 0.001 meter. The detailing is too much. So, to be precise, the least count of this is 0.001 meter. The least count of this measurement is 0.1 meter. Mathematically, these two numbers are same, the units are same, but the measurements are not the same. This number is measured using an instrument of least count 0.1 meter, right? I hope you are clear with least count. I have explained it in the previous session. But this measurement is done with an instrument of least count 0.001 meter. That's the basic difference for considering the trailing zeros of a number with decimal point as significant. Okay. So these are few rules to find or to get the number of significant figures in a given number. Okay, so if now from now onwards, if you have if you are asked to find the significant figures of any number, you should be able to find it using these rules. Okay, remember these rules, and these rules are important. They are asked in boards also. And now the question or the doubt that might arise is, say I have a number like this, say 5 meter. Then you might ask, sir, I can write this 5 meter as 500 centimeter, and I can also write this as 5000 millimeter, right? Yes, you can write it as such, but what is always suggested is not to put trailing zeros, not to include zeros for the conversion of units. Instead, one should choose to put the powers of 10 to convert the value. Okay, powers of 10 should be used to convert the value. For example, now if the value is 5 meter and I want to convert it into centimeter, mathematically they are fine, but it is suggested to write this as this 5 centimeter as 500 centimeter as 5 into 10 to the power of 2 centimeter. So this 10 to the power of 2 is insignificant. Any power of 10 with the value is insignificant. Keep that in mind. And now in this number, the same way it should be written as 5 into 10 to the power of 3 millimeter. So now number of significant figures in this actual measurement is 1. The converted value is also 1. The other converted measurement is also only one significant figure. These are not significant. So one more important point is conversion of points, conversion of values from one system of unit to the other system of unit will not alter the significant figures in a given number. Okay, if you convert it from one unit to the other unit, this number of significant figures will remain the same. Okay, right. So the same rule follows even if we are converting it into the other units. Like I just want to convert it to other units. If I say I want to write this as 5 should be written as, say, in kilometers, 5 meter. If I want to express this 5 meter in kilometers, it will be 5 into 10 to the power of minus 3 kilometer. So now I have converted from meter to kilometer, but the number of significant figures still remains the same, which is 5. And similarly, now you might think, sir, if I have a number something like 2.50 meter, then if I want to convert it into centimeters, then in centimeters we generally directly write it as 250 centimeter, right? Isn't it? But no, this is not the right way of representing it, because see, for the same measurement in meters, we have 3 significant figures here. 2 is significant, 5 is significant. This 0 is also significant because it's a trailing 0 after decimal point. After decimal point, or a 0 for a number with decimal point. But when we convert this, it becomes 250, and we have only 2 significant figures, and this 0 is not significant because it's a number, it's a trailing 0 for a number without decimal point. So now which one is right? So according to this we have 3 figures, according to this we have only 2. So to avoid this confusion, what we need to do is we should retain the same measurement, 2.50. When we convert, the same rule should be followed. We should put the powers of 10, 5.0 into 10 to the power of 2 centimeter for the conversion, and using this case we can now see we still have only 2 significant figures, 2 and 5. Okay, I'm sorry, three significant figures, 2, 5 and 0. Okay, so we have successfully converted. At the same time, we have retained all the significant figures, all the three significant figures. Okay, so this is the using the powers of 10 is the proper way to convert a measured number, because that way will not alter, will not change the significant figures in the number. Clear? So this is about rules for writing significant figures. Okay, now we'll see for mathematical operations involved in measurements, how many digits has to be retained after calculations. Okay, see, now it's about retaining rules for mathematical operations with significant figures. It's rules for arithmetic operations with significant figures. See, again, when I say mathematical operations, we have basic operations, like we'll choose the basic operations again: addition, subtraction, multiplication and division. For addition and subtraction, the rule is as follows. Okay, for addition and subtraction, the rule is we should retain as many digits after the decimal place in the given numbers with the least number of decimal places. Okay, so you'll understand once I write everything. For addition and subtraction, we should retain as many digits as many digits uh, as in the least decimal places, the least number of digits in the decimal places, or least number of digits in the decimal places among the given number. So when I say addition and subtraction, the number should we will have two numbers and we will add them or subtract them. Okay, say I am measuring any quantity and we have something like C is equal to A plus B. So in this kind of situation, if the values of A and B are as follows, let me take the example. If the value of A is 5.36 and the value of B is 4.824. Now, if I write the value of C, then the sum or the total that I get is 4.824 now. So it's going to be 4, 8, 3 plus 8 is 11, 1 carry 10. So it's going to be 10.184. This is the actual mathematical way of keeping the answer. But when we are adding two quantities, okay, adding two values like this from measurements, the final value C, the sum of those two, will or should have the least number of decimal places, okay, least number of decimal places, as many as in the among the two given numbers. So among A and B, how many numbers do we have? We are adding only two numbers, A and B. What is the number of decimal places in the number A? It is only 2. 3 and 6 are the decimal places of A. So number of decimal places for A is 2. Number of decimal places for B is 1, 2, 3. It is 3. So according to this rule, for writing the sum of two measured values, I should retain the number of decimal places, as many number of decimal places as the least number of decimal places present among the given numbers. So among these two, A has the least number of decimal places, only 2. Compared to B, A has lesser number of decimal places. So I should round this off. Okay, I should round this number to 2 decimal places. Okay, because this number is the sum of A and B, and among A and B, A has the least number of decimal place, which is 2. That is why I should also keep the sum C with only 2 decimal places. Okay, that is the rule. So C is equal to 10.18. This is how I should round off for when we do addition and subtraction. So the next one is similar. It's for multiplication and division. Okay, both the operations are considered. Now the rule is different. It's not the decimal places which has to be considered. This time for multiplication and division, we should retain. Okay, we should retain as many digits as in the number with least number of significant figures. With least number of significant figures. Okay, so this sentence is more meaningful. You just make this sentence look like this. Okay, convert this. The only difference is in the place of multiplication you put addition, in the place of division you put subtraction, and in the place of decimal places you put significant figures. That's it. Okay. So should retain as many digits as in the number with the least number of significant figures. So instead of the decimal places, we should now retain the significant figures. For example, if I have two numbers, say 5.2 into 2, what is the product? Mathematically, it's very simple. The product is going to be 10.4, but I should not take the entire value. Instead, I should round off this value to the numbers. Okay, to what numbers I should round it off? To the same numbers as in the significant figures, least number of significant figures. So we have two numbers given here. One is 5.2 and the other is 2. This number, the second number here, it has only one significant figure. The first number has two significant figures. Among these two, the second number has least number of significant figure, which is 1. So the product should also have only one significant figure. Okay. So 5.2 is one number, this 2 is the other number, which are multiplied to get the product. And the rule says the product should have the least number of significant figures. Okay, the least number of significant figures. Product should have the significant figures equal to the least number of significant figures among the given numbers. You just understand it. It's very easy. Don't need to memorize these things much. Okay, they will be helpful in problems. These statements and all. That's fine. You just make your sentence and write them properly. That's fine. So here among 5.2 and 2, 2 has the least number of significant figure, only 1. Okay. What is the significant figure of 5.2? 2. What is the significant figure of 2? It is 1. So the product should also have only one significant figure. But what is the significant figure that we have? We have two significant figures in the product. I should round it off to one significant figure. How do I do that? I will make this as simply 10. Okay, by making this as 10, by rounding it off to 10, now in this number I only have one significant figure, isn't it? This 0 is insignificant, so I only have one significant figure, and this is how we should round off when we have product of two measurements. Clear? So these are the rules which should be followed while considering the product or the sum for this. Okay, and the same rule also follows for division, and this the same rule, the first rule also follows for subtraction. Okay, addition, subtraction, least number of decimal places. Okay, multiplication and division, least number of significant figures. Okay, keep that in mind. Now the next part is how to round off the numbers. So now in these two situations which we discussed now, we had a situation of rounding off the numbers to lesser numbers, to the lesser number of digits. So now we will see what are the rules to be followed while rounding off the given numbers to lesser decimal places or lesser number of digits. So it's about rounding off the uncertain digit. So the rules for rounding off the uncertain digits is as follows. If the insignificant digit to be followed, okay, if the insignificant digit to be followed, if the insignificant digit to be followed is not followed, to be dropped, okay, if the insignificant figure to be dropped is greater than 5, then the preceding digit, previous digit, okay, then the preceding digit is raised by 1. For example, say I have a number 5326. So if I have a number 5326, and if I am asked to round the number off, okay, round off the number to 3 digits, okay, if I am asked to round off the number to 3 digits, then I should have only 3 digits left, so the 4th digit should be removed. How do we remove it? I should keep either 532 or I should keep 533 when I want to remove 6. Very easy. So since this is the insignificant number now, okay, this is the insignificant figure because I have to remove it out of the number. So if this insignificant figure is greater than 5, okay, if the insignificant figure is greater than 5, we will round it off to 532. We will round it off to 533. So that's what the rules is. Very simple. Okay, since this value is greater than 5, instead of 2, I'll write 3 and round it off. So after rounding it off to 3 digits, it will become 533. Okay, because 6 is greater than 1. That is why the preceding digit is raised by 1. Okay, that's it. Next, the same way, if the insignificant digit to be dropped is less than 1, less than 5, so less than 5, then the preceding digit, again the preceding digit is left unchanged. Preceding digit is left unchanged, which means if I have the same similar kind of numbers like 8432, if this is the situation and I am asked to, okay, so sorry, here I have rounded it off to 3 significant figures, but I have reduced the number. I should not reduce the number, I should keep the 0. Okay, after keeping the 0, it will become 5326. Rounding off to 3 significant figures becomes 5330, right? In the same way, if I want to round off this 5432, say this time to only 2 decimal places or only 2 digits, okay? If I am asked to round it off to 2 digits or 2 significant figures, then I should write 8. See, this is the insignificant figure now, right? Because I should round it off to only 2 places, 2 significant figures. So this 3 and 2 are not significant because we are going to drop it. Okay. If I am not going to drop it, this will be significant. These 2 will be significant for us. That's the basic rule. But since I am asked to drop these 2 numbers, I should see the number which is 3 here, and this 3 is insignificant because I have to drop this. Even 2 is also significant, but the later one is has the more value in the 10th place. That's why I am considering this. This 3 being insignificant and less than 1. So the preceding number 4 should be left unchanged. So if I am asked to round this 8432 to 2 significant figures, it becomes 8400. Okay, it becomes 8400. And next, the question that comes is, okay, fine, if the insignificant figure is greater than 5, we will increase the preceding number by 1. If the insignificant figure is lesser than 5, we will leave it unchanged. But what if the number, the significant digit in the number, non-significant digit in the number is equal to 5? Okay, when the insignificant digit in the number is equal to 5, then we should look for the preceding term. What kind of value do we have in the preceding value, in the preceding digit? For example, so the conditions goes as such: if the insignificant digit to be dropped is equal to 5, okay, is equal to 5, then, and now if it is equal to 5 and one more condition has to be checked. If this number which I want to drop is now equal to 5, if that is the situation, then I should look for the preceding term. Okay, before I make the change in the preceding term, I should look what kind of preceding term do I have. Equal to 5 and the term and the preceding digit is odd, or let me take even first, is even, then, okay, see, I'll give you the example, now then you'll answer. If the preceding digit is even, then the preceding digit is left unchanged. Okay, right. So now, if next question that comes is, if the insignificant digit is to be dropped is equal to 5, again equal to 5, and the preceding number and the preceding digit is odd, okay, then the preceding digit is raised by 1. So let me take an example for both of them together and answer. So example for both of them together is as follows. Say I have a number 5, okay, 3 2 1 2 5. So if this is a number and if I want to round off this number to 4 significant figures. Now in this number I have 5 significant figures including the last 5, and I want to round it off to 4 significant figures. Then I should follow the rule, okay, it is either the uncertain digit or the insignificant figure here which I should remove is equal to 5. If that is the situation, I should look for the preceding term. If the insignificant digit is equal to 5 and the preceding term is even, then I should leave the preceding term as it is. Okay, then I should leave, because since 2 is even, I will not make any change in the value in the digit 2, and I will retain it as such, and hence it becomes 3 2 1 2 0. So now I have rounded off this number to 4 significant figures as follows. But if I have the number as such, say the same number, instead of 2, say now I had 3 5, 3 2 1 3 5. If this is the situation and again I want to round it off to 4 significant figures, then it becomes 3 2 1. So this is the insignificant figure to be dropped. So this is equal to 5. So then what should I do? I should look for the preceding term, and the preceding term that I have is odd in nature. Okay, the value is odd, 3 is odd. So if the number is odd, then I should increase the value of this 3 to 4 by 1. Okay, 3 to 4 and round it off. Clear about this? Very easy. If the insignificant figure is greater than 5, then you raise the preceding term by 1. If the insignificant figure is less than 5, then we'll retain the preceding term as it is. If the insignificant figure is equal to 5 and the preceding digit is even, then we will retain it as similar. Finally, if the insignificant figure is equal to 5 and the preceding term is lesser than 5, if the preceding term is odd, in such a situation we will increase the value of the preceding term by 1. So this is everything about rounding off techniques in the numbers with uncertain digits. Okay, we should follow this when we are asked to do such problems in the exam. Okay, see these rules. Excuse me. See, these rules should be kept in mind for such problems which are based on these rules itself. Because when you solve different numerical problems from the next chapter, these rules are not that much considered completely in the problem. Okay, but the problems based on this chapter, particularly units and measurements, must be considered, must be followed with these rules. Okay, from next chapter onwards, we are not going to follow all these rules exactly, so don't need to bother about applying them every time you solve any problem. We should only concentrate on this particular chapter, the rules for this particular chapter, for the problems of this particular chapter. Okay, fine. From the next session, we'll start with dimensions. Thank you.